name is Sean Bergen, and I'm a member of the CompSysNet educational team. In this module, we'll talk about the FAIR principle. So, what are the FAIR principles? The FAIR guiding principles are a group of 4 desirable characteristics, plus the steps needed to achieve each, that help researchers maximize the impact of their software and data outputs. The creation of these principles was the product of a consensus reached between members of academia, industry, funding agencies, and scholarly publishers in an effort to support more efficient discovery and reuse of published work. As scientists and scholars, we are always hoping to maximize the impact of our research. FAIR principles provide a series of steps that can make your work more accessible to other researchers and enable your research to provide the foundation for future research. So, why make your model fair? First, researchers need to be able to discover a given piece of software when they search for relevant terms. Otherwise, the work will stay unnoticed. Second, if the software is open access, or the researchers in question have the right credentials, they must have a way to retrieve it. Then, they need to be able to understand the software's purpose and the main features, and finally be able to run it and use it under the aims of a new study. This process, plus the actions needed from researchers and archival infrastructure to facilitate each step, is what the FAIR acronym summarizes: Findable, Accessible, Interoperable, and Reusable. So how do you make your model fair? And in order for your model to be fair, you must follow the instructions listed under each letter. First, F stands for Findable. Research outputs cannot be impactful if other researchers are not likely to find out about their existence. Practices that improve the findability of research software include using searchable registries of archives, assigning a persistent identifier or DOI, and providing rich and descriptive metadata. Best practices, considerations, and examples of these tools will be further discussed in the modules Metadata and Archiving Your Code. A stands for Accessible. Once researchers have become aware of a piece of software, they need to be able to access it if they have the authorization or right credentials. A research object is made accessible when deposited in a trusted archival service that uses permanent identifiers for retrieval. Also, metadata associated with the object should remain accessible even when the object is no longer available or has restricted access. I stands for Interoperable. Research outputs that are useful to others have to be adaptable to new use scenarios. While it can be difficult to future-proof your software and data, it is helpful when knowledge is represented using formal and accessible vocabularies, formats, or platforms that are accepted by the community. Also, software objects can be more interoperable when aspects like the definitions of variables used, the software it depends on, and the input and output formats agree with the standards used within the community. The letter R stands for Reusable. If you want researchers to assess your research object's relevance for their own study, they need to understand the context in which it was produced and the nature of its contents. In the specific case of research software, it is vital to provide high-quality documentation describing its purpose, limitations, functionalities, and the steps needed to successfully run it. This topic will further be explored in the documentation module. Additionally, it is necessary to provide a clear usage license so that researchers know how and if they can modify your software in the future. To learn more about license options and their meaning, visit the license module. It's important to note that fairness of a research object is not affected by its availability. Therefore, open access is not a prerequisite for the implementation of the FAIR principles. Also, fairness does not guarantee the quality of a research object. It only evaluates how much its authors facilitated its reuse. Therefore, a model of the solar system in which the Earth is the center could be considered fair, even though we all know that this is inaccurate. Major funding bodies are increasingly promoting the adoption of the FAIR principles to maximize the impact of the projects supported. At the individual level, Authors benefit from following the FAIR principles because they serve as a guide to publish research objects that are more likely to be used and therefore cited. At the same time, the incremental availability of more FAIR objects allows for more efficient discovery and reuse of previous work, which benefits the scientific practice of building upon past discoveries. In the next module, we'll talk about metadata, what it is, and how it's different from documentation.